Welcome to Clear Coding. I'm your host, Stephen Clary. Today's video is one of a series of videos that I uploaded to Vimeo almost 10 years ago, which is why I'm going to look completely different for the rest of this video. But this video is kind of exploring how asynchronous code used to look like before async and await what came on the scene. So, hope you enjoyed this blast from the past, and I'll see you on the other side. Hi, I'm Steve Clary. And this is the first in a series of videos where I'm going to be looking at the question, why do we want the async and await keywords? There's a few overview videos that I've already done. They're freely available. I'll post links below. And I cover related topics in these overview videos. The first one, I answer the question of why do we want asynchronous code at all? And the short answer is because it provides two benefits. On the client side, we have a more responsive user interface. On the server side, we have a more scalable server, that is a server application that makes maximum use of its resources. And the second video, I went into the question of why is this such a big deal right now? And the short answer to that is because when we have mobile applications, they require a responsive user interface. And when we have cloud applications, they give you financial benefits if your server is scalable, if it makes maximum use of the resources that it has. And these two dovetail very nicely into the benefits that we get from asynchronous code. That's why it's growing so big right now. And the other overview video that I'm going to link to is how languages have adopted async and await over the last few years. And this is an interesting phenomenon because we've got some very different languages with different goals that are run by different groups of people, very different groups of people that are all looking at async and await, and they're saying, this is good for us. We want this in our language. And so they've been adopting async and await. Today we're looking at why. The short answer, the one sentence answer is that async and await allow you to write maintainable asynchronous code. That's the key, maintainable asynchronous code. So we're going to be looking at this in detail over the next few videos and seeing exactly how it is that async and await is better than other asynchronous code approaches. We're going to look at a history of asynchronous patterns, so to speak, starting with events way far back in time. We'll start with event-based asynchrony, and then we're going to move forward into callbacks, or as it's more formally known, continuation passing style. And then we'll take the jump into futures and continuations, and the benefits that those bring. And then finally we're going to look at async and await, and how this one really is the easiest to write, the easiest to understand. It's the easiest code to maintain out of all these asynchronous patterns. And as we go through this is a very language agnostic talk. Okay, we are over this entire series of videos. We are not focused on .NET. We are not focused just on JavaScript. In fact, I'm going to use a fake language. I'm not even going to use a real language in all of my examples. Every language has its own little quirks where, this part is easier and this part is harder. But what I'm going to describe here is overall patterns that are true across all of these languages. So I'm going to use a fake language that's applicable to any language that you're using, any imperative language that you're using, so including Python, JavaScript, TypeScript, C, all the way back to C, C#, C++, Java, Visual Basic. Any of these languages are perfectly applicable to what we're looking at over these patterns. And we're going to solve a couple of problems. And we're going to look at how these patterns solve these two problems. Programming, if you think about programming just in a very general sense, I would say that programming is the art of taking a problem, breaking it down into many smaller problems, solving those smaller problems, and then composing those solutions into an actual application. And that's a very broad overview, but that's the way that I think about programming. You break down the big problem into small problems, and then you solve each one of those small problems, and then you compose all of those solutions into one application. And when you're writing asynchronous code, it doesn't really change how you break your problems down or anything like that, but it does change how you compose them together. This is where asynchronous code starts to have issues, is in the composing of various asynchronous operations into a higher level asynchronous operation. And that's where people start running into problems, is this final step of composition. So we're going to be looking at, using this fake language, we're going to be looking at how each one of these asynchronous patterns, how they look like, what the code actually looks like, how maintainable is it when we compose together different asynchronous operations. So the first problem that we're going to be looking at is we want to download a string from the internet, and we're going to save it to a database. Downloading a string from the internet and saving it to a database are both I/O operations, so this is a very natural fit for asynchronous code. And we'll take a look at the different asynchronous patterns and what the code actually looks like when they solve this problem. The second problem that we're going to look at is a little bit more complicated. We're going to download one file from the internet that is like an index, and then we're going to look inside of that index. We're going to parse out any number of child URLs, and then we're going to download each one of those one at a time. And when those are all done, we're going to save all of that data also into a database. So once again, we're downloading from the internet and saving to a database. This time, it's tweaked a little bit so that we have some state that we have to keep track of. And then this is where we'll see a lot of those asynchronous patterns get really complicated. But once again, the synchronous code is very straightforward. So next time, we're going to launch things off, and we're going to use the event-based asynchronous pattern within our fake language to download a string from the internet and save it into a database. That sounds easy, doesn't it? You might be surprised.